So today's topic for our lecture is related to steering system. So for that purpose, I want to share my screen first. So if we see steering system, then in that steering is the term applied to the collection of components, linkages, etc., which will allow a vehicle to follow the desired course. An automobile is steered with the help of steering gears and linkages, which transfer the motion of the hand-operated steering wheel to the pivoted front wheel hubs via steering column. Means, in case of automobile, one wheel is provided at the driver's place, and in case of four-wheeler, if we turn that wheel, then the column which is attached to that wheel also rotates, and due to that the linkages which is attached to this column is also rotating or moving. The other parts that are used for the steering a vehicle are steering wheel pads, then steering shafts, steering boxes, steering arms, and steering stabilizers. So these are the components which is related to this system. These parts are made of durable materials like stainless steel, iron, aluminum, copper, magnesium, titanium, platinum, rubber, plastics. So these are the components. These are the materials which is related to different components in case of the steering system. If we see the components of a conventional steering system, so the diagram shows that same. If we see here, this is the steering column, drive shaft, okay, and actually steering wheel is attached at this end. So steering box is also shown here. So linkages is provided, and this is arm, and that arm is called as drop arm. Drop arm is again connected with this hinge type of joint, and here also the joint is provided, and this is drag link or ball joint is provided here. After that, ball joint is connected to the drag link arm, and this drag link arm is connected to the that stub axle. This is the stub axle. Actually, two stub axles are provided on the one axis, or okay, one axis, that is front axis or rear axis. If we consider this diagram, this is the front axis, because steering mechanism is attached or provided on the front side of the vehicle. So these are the stub axles. If we see in this diagram, this is the track rod. Track rod is used for stabilizing the vehicle. If the vehicle gets roll over, then in that situation, the tie rod makes this vehicle in stable condition. Okay, that is the function of this tie rod. This is the track. Then the next is steering seat. Then axle beam is provided. If we cut this axle beam, the cross section is I section, because it gives more amount of strength as compared to different cross sections. This is track rod arm. This is kingpin. The kingpin is used to connect the stub axle with this drag link. So in this way, the components we show in this diagram. This is the steering system components. If we see the functions, it helps in swinging the wheels to the left or right. If we move or if we turn that wheel, then if we turn that wheel, steering wheel towards the left direction, then the front wheels are also turning in the same position or same condition. If we turn that wheel on the right side, then both the wheels are also moving towards the right direction. It converts the rotary movement of the steering wheel into angular turn of the front wheels. Okay, actually we make the rotary motion on that steering wheel, and that steering wheel is attached with these different components, and due to that linkages, that rotating movement is transmitted into angular turn. So at some angles it is turning, that wheel gets turning. Okay. Then if we see another function, it multiplies the effort of the driver by leverages in order to make it fairly easy to turn the wheels. So here, mechanical advantage, this is the concept used at the time of applying the force on that steering wheel. If we just turn the wheel, then for turning that actual wheels on the ground requires large amount of force, but we can easily turn the steering wheel and that wheel of the vehicle gets turning. So in this case, we use the leverage. The next is it absorbs a major part of the road shocks, thereby preventing them to get transmitted to the hands of the driver. So these are the different functions. If we see the geometry, the term steering geometry, also known as front end geometry. That is the angular relation between suspension and steering parts, then front wheels, road surface. Okay, if we consider all this together, that is related to steering geometry. Because alignment deals with angle and effect steerings, the method of describing alignment measurements is called steering geometry. There are 5 steering geometry angles. That camber angle is there, caster angle is there, toy, then steering axis inclination, and toy out on turns. If we see the different sketches, which is again related to the mechanism. So in this diagram, we see camber. Camber is nothing but if we consider the wheel is turned inside or in the inner direction of the vehicle, then the vertical direction and between this wheel axis, that angle is called as camber angle. If we consider this is the suspension, so axis of this suspension towards the vertical axis, this angle is called as caster. Then front of the vehicle, this is X and this is toy in, that is YX. So this is toy in condition. If the vehicle move out in the outward direction, that situation is called as toy in. In the second diagram, here we see the geometric center line. Actually, this is the middle line in that vehicle. Then thrust line is also shown here and thrust angle is also shown here. So angle between the geometric center line and thrust line, that angle is called as thrust angle. In the next diagram, here we see the included angle, then camber. These are the angles which shown in this diagram. If we see the steering gear is device for converting the rotary motion of the steering wheel into straight line motion of the linkage with a mechanical advantage. So this is the main purpose for providing the steering gear. If the steering wheel is connected directly to the steering linkage, it would require a great effort to move the front wheels. Therefore, to assist the driver, a reduction system is used having a steering ratio. The ratio between the turn of the steering wheel in degrees or handlebars and the turn of the wheels in degrees between 10:1 to 24:1, the actual value depending upon the type and weight of the vehicle. A higher steering ratio means that you have to turn the steering wheel more to get the wheels turning, but it will be easier to turn the steering wheel. A lower steering ratio means that you have to turn the steering wheel less to get the wheels turning, but it will be harder to turn the steering wheel. Larger and heavier vehicles like trucks will often have higher steering ratio, which will make the steering wheel easier to turn. In normal and lighter cars, the wheels becomes easier to turn. So the steering ratio doesn't have to be as high. In race cars, the ratio becomes really low because you want the vehicle to respond a lot quicker than in normal cars. The steering gears are enclosed in a box called the steering gearbox. there are many different designs of steering gearbox. If we consider the designs in steering, worm and wheel steering gear, then worm and sector steering gear is available. Cam and lever peg steering gear is available. Then recirculating ball steering gear mechanism is available. Rack and pinion steering gear mechanism is available. So all this is related to steering gears. If we see worm and wheel steering gear, see this diagram. In this diagram, we show different components. So this is the steering shaft, or this is also called a steering column. The steering column is shown here, and on that steering column, worm is connected. Then as steering shaft rotates, then due to that motion, rotary motion, worm is fixed to the steering shaft. So worm is also rotating. As worm gets rotated, worm is connected to the worm wheel. Due to that motion, worm wheel rotates or connected to the worm wheel, and as the effect of worm turning, the worm wheel also rotates. As the worm wheel rotates, it is attached to the different linkages. Then cast case is available, then drop arm is available, cover is available. Okay, all these components are related to the system. Then drop arm is moving, and due to that action, it gets working. The system consists of worm wheel, which is carried in bearing in a cast iron case. The case is made in halves. The outer end of the worm wheel is fixed to drop arm, which is having ball end to connect the side rod. The side rod is connected to the steering arm, which is fixed to the stub axle. The worm, which is keyed out to steering shaft, have a mesh with the worm wheel. The steering wheel is mounted at the upper end of the steering shaft. When driver rotates the steering wheel, then drop arm moves either backward or forward direction. This motion results in motion of the stub axle. Motion of the stub axle. So as the worm wheel is rotated, then this drop arm is moving towards the backward direction or forward direction. Depending on this motion, the results in stub axle movement. If we see the next, worm and sector steering gear, in this type of steering gearbox, the end of the shaft from the steering wheel has a worm gear attached to it. It meshes directly with a sector gear, so called because it's a section of a full gear wheel. When the steering wheel is turned, the shaft turns the worm gear and the sector gear pivots around its axis. As its teeth are moved along the worm gear, the sector gear is mounted on the cross shaft, which passes through the steering box and out of the bottom where it is spline, and the pitman arm is attached to the splines. When the sector gear turns, it turns the cross shaft, which turns the pitman arm, giving the output motion that is fed into the mechanical linkage on the track rod. The box itself is sealed and filled with grease. In actual case, the worm wheel is not essential as it is having only partial rotation. Hence, in this type, only a sector of wheel is used instead of worm wheel. If we see the next, cam and lever, or it is also called as peg steering gear. Here, a helical groove is formed at the bottom end of the steering wheel shaft. The helical groove engages the projected pin of the drop arm spindle lever. The drop arm is made of rigid with lever or peg by spline spindle. If we see this diagram, in this diagram, this is the helical groove. This is pin projected in groove. This is the steering shaft. This is the column. Then this is the bearing. Washer for play. This is the casing. And this is the drop arm. The spline shaft, drop arm spindle lever, and this is the bearing. All these components are related to cam and lever or peg steering gear. The to and fro motion is obtained at the drop arm when the steering wheel shaft is turned. This motion results the turning of the stub axle. The end play of the steering wheel shaft can be adjusted by putting a suitable washer at the lock nut. The meshing of the projected pin in helical groove is also adjusted by a screw pivoted at the end of the lever spindle. In the recent models, the projected pin is made in the form of a roller. The projected pin may be 1 or 2 in a number according to they are referred as cam systems and mechanisms. Next type is recirculating ball type steering gear. It consists of a worm at the end of steering rod. A nut is mounted on the worm with 2 sets of balls is grooves of the worm in between the nut and the worm. The ball reduces the friction during the movement of the nut on the worm. The nut has a number of teeth on outside which mesh with the teeth on a worm wheel sector on which is further mounted the drop arm. When the steering wheel is turned, the balls in the worm roll in the grooves and cause the nut to travel along the length of the worm. The balls, which are in 2 sets, are recirculated through the guides. The movement of the nut causes the wheel sector to turn at an angle and accurate the link rod through the drop arm, resulting in the desired steering of the wheel. The end play of the worm can be adjusted by means of the adjuster nut provided. To compensate for the wear of the teeth on the nut and the worm, the two have to be brought nearly to each. So to achieve this, the teeth on the nut are made tapered in the plane perpendicular to the plane of the figure. If we see the next type, that is recirculating ball type steering gear. In this system, the steering shaft is provided, and here the ball nut rack is provided. Recirculating ball bearings are available. This is the worm gear. This is the sector gear. This is the pitman arm. In this case, rack and pinion steering is quickly becoming the most common type of steering on cars, small trucks, and SUVs. On most cars, it takes 3 to 4 complete revolutions of the steering wheel to make the wheels turn from lock to lock. The rack and pinion gear set does 2 things. It converts the rotational motion of the steering wheel into the linear motion needed to turn the wheels. It provides a gear reduction, making it easier to turn the wheels. A rack and pinion gear set is enclosed in a metal tube, with each end of the rack protruding from the tube. A rod called a tie rod connects to each end of the rack. The pinion gear is attached to the steering shaft. When you turn the steering wheel, the gear spin, moving the rack. The tie rod at each end of the rack connects to the steering arm on the spindle. So this is the rack and pinion steering. If we see this diagram, this is pinion gear. In this diagram, tie rod is shown, tie rod end is available, then rack housing is available. If we see on the right side, basic rack and pinion components, this is the steering wheel. The column is attached to the worm is connected to the rack. Okay, in this way, the motion takes place. The linkage is moving and which is connected to the assembly near to the wheel. Power rack and pinion. When the rack and pinion is in power steering system, the rack has a slightly different design. Part of the rack contains a cylinder with a piston in the middle. The piston is connected to the rack. There are 2 fluid ports, one on either side of the piston, supplying higher pressure fluid to one side of the piston, forces the piston to move, which is in turn moves the rack, so providing power assist. If we see this diagram, this is the rack, pinion, fluid lines, rotary valves, steering column towards the reservoir from pump, and this is the pinion. Power systems are also available nowadays. Hydraulic power system is available. Then this diagram shows the hydraulic power steering. How car steering works, that is rotary valve is provided, steering gear is provided, pump is provided, pulley is provided. In this diagram, fluid reservoir is shown, then return hose fitting, then vane is provided, rotor is provided, pressure hose fitting is there. So in this way, we finish our today's lecture, that is steering systems. Thank you.